Hey guys.
We are live again. How many weeks have we been doing this?
Ooh, four?
This 4 weeks in a 4 weeks in a row.
4.
Hey, that's some consistency.
Yeah.
No,
I hope y'all are enjoying this because I know we are.
Hey, so we're happy to be back. Doing this for you guys again today. I know last week a lot of you kids out there, you had spring break last week, and I know it was a different spring break than you normally have, but I think. Sorry, you might be getting a little feedback right here. I gotta turn my sound off.
Yeah.
All right, got it. But I know you guys have been back, I think, doing some schoolwork this week and things. So hopefully this is kind of just a fun little learning thing that we can do with you guys today. So the last couple of weeks we've talked about bones a lot, and we talked about our skeleton and how it gives us shape and how it allows our bodies to move. And today we're going to talk about something else that's not really about bones, but it's about parts of our anatomy that let our bones move. So
Related to bones,
associated with bones and related to bones. Yeah. So we're gonna talk about muscles today. I think Miss Suzanne has a couple of cool videos for us to start out with, kind of about some problems people can get into with their muscles sometimes. So we're gonna show you a few videos of some athletes here and kind of how we use our muscles to run and jump. They help us. They help our bodies move. They are what actually moves our bones. By muscles attached to tendons and then attached to bone. And here are some athletes who are really using their muscles, and sometimes some bad things can happen. So let's see what we got here.
I don't know if y'all know who Usain Bolt is. He was at one point the fastest person on the planet. He might still be.
Yeah.
I don't really keep up with that anymore.
Yeah.
But in his very last race, he actually had an injury.
So
you can see he's the guy in the yellow. Oh! Yeah, that looks like it hurts.
So here's a guy who's the fastest guy in the world, but man, when he has a muscle injury, and I think it was his hamstring.
Yep, he pulled a hamstring.
We'll look at that in a minute, but yeah, that's that can stop you in your tracks. And let's what we got here? We got baseball.
Here's a I'm showing you this because this can happen in any sport. Make sure they can see that.
This can happen to you guys when you're younger.
So let's take a look at the guy running through first.
Stanton finally finds his groove.
Oh!
You see him grab his leg right when that thing, right when his hamstring muscle. This is a hamstring too, right?
Yep, there's another hamstring.
Yeah, and those are real common injuries in baseball too. So.
Taking them to the ground.
Our muscles, when they're functioning well, they can make us run really fast. But when, but if we get injured, man, it can stop you in your tracks.
And then here's another sport, basketball. This is a guy that let's take a look, see what happens here. Oh, did you see that back leg just go straight out?
That was a little harder, but that's a bad injury.
Yeah, I'm not sure what that is.
I got you. Okay. So that last one, and we'll talk about this in a minute, that last one was an injury that happened actually to kind of where the tendon attaches to the bone. And so our muscles are all attached to our bones by tendons. And that was I believe
that guy, yeah, that was an Achilles tendon or the calf, back of your lower leg that you think about.
So we'll talk about muscle injuries in a few minutes, but we're going to start out kind of just with a little brief kind of introduction to
maybe we're about that too.
A brief introduction to just muscles and the anatomy and what they do and how they work and how they contract. So we're going to get started with a little slideshow here. So let's see what we got.
All right, muscles. Y'all know we have over 600 muscles.
I'm going to be quite honest. I actually didn't know that till yesterday.
Yeah.
Some of the trivia things we kind of find out. We learn a lot when we do these things.
And the reason there's not an exact number is because there's some muscles that some people have and some people don't have. We might talk about that a little bit later. But there's one in particular that we deal with from an orthopedic standpoint that some people have and some people don't have in their forearm. Mm-hmm. So a little trivia here. Does anybody know what the smallest and the largest muscle is? We'll give y'all a little bit to...
We'll give you a little hint on the smallest muscle. We've talked about the smallest bone in the previous...
and this muscle attaches to that bone.
Video, yeah. Okay. That should be helpful for some people.
So if any of y'all were watching our first week, we talked about all the smallest and the biggest bone, but now we're talking about the smallest and the biggest muscle. So
okay, and then what's the largest muscle? Okay, the smallest. We'll give people a little chance.
So
as
all right,
we go on to see if they'll see if anybody wants to chime in and try to
Y'all,
answer this. And we got to remember to give them.
I was about to say somebody better be giving us some answers, or else we're probably going to forget. So all right, so we talk about types of muscle. We always think of the muscles. You know, when you make a muscle, I don't know if y'all can see this, but we always think about muscles that you can see. Yeah. Yeah. Well, I have been working out. Not really. All right. So, but we always think about the muscle that moves us, which is we call skeletal muscle, that allows the body to move. It attaches to the bone, the skeleton, like we've talked about in the past, that moves the bones. But there's also other kinds of muscle. We have muscles. Type of muscle called smooth muscle that we find in different organs in the body, like the stomach. They are in the intestine, in the bladder. It's what the stomach and the intestine. That's what moves the food that you put into your mouth till it comes out. It's all muscle that's moving it through your body, and that's smooth muscle. And then cardiac muscle. Cardiac,
special type of muscle in the heart.
It's a different, special type of muscle in the heart. Cardiac is just a word that describes anything related to the heart, and that's what keeps the heart beating. You know, we over here.
Those are involuntary muscles. Like you don't have to think about making your heart beat.
Like if I wanted to move my finger, my brain's telling my finger telling me to move that finger, but you don't have to tell your heart to beat. It just beats.
Yeah, or when you eat, you don't have to tell your gut to digest your food. It just does it, and there's muscles involved in doing all those things. And so some of our muscles are voluntary, we have control over, and some of them we don't have to think about. Thankfully, we don't have to think about. Like our diaphragm is a muscle that moves our lungs up and down when we breathe, and we don't have to think about moving that muscle. So that would be really exhausting if we did.
That would be.
Yeah. So,
that would be.
All right, so those are kind of about the types of muscle, and let's move on. Just kind of a picture of different things like we talked about. Skeletal muscles are the muscles you probably think about. Those are the muscles that move your arms, move your legs. Smooth muscle, like in the that's a picture of a stomach.
So this is skeletal. There's your stomach.
Yeah.
Smooth muscle. This is actually the esophagus coming in. The esophagus is what connects your mouth, the back of your mouth, to your stomach.
Yeah.
It's a big long tube, and that's all. It's all muscle that moves that food down into the stomach and then into your intestines here.
And then over on the right, that's actually a picture of a heart.
Yep.
You know, sometimes I think these things are kind of we see these things a lot and think about them a lot, but you guys might not ever know. You might not know that's what your heart looks like, but that's what the heart looks like. And again, there's cardiac muscle there in the different chambers of the heart that allow the heart to contract.
What we're going to talk about primarily today is going to be skeletal muscle.
Yeah, because that's what we deal with the most in orthopedics. You know, what we do in orthopedics is we treat conditions of the bones and the joints, and so because the muscles help move the joints, sometimes we have to deal with injuries or different problems with the muscles, or sometimes actually we're just helping people to strengthen their muscles because it can help with some other types of problems that they have. So a lot of different things we do there.
All right, James. James is coming up with some answers here.
Yes, Dr. Google.
Yes. Hey, James, you would be correct. You would be correct if you're guessing that that's the smallest muscle.
Right. Hey, I'm sure. I'm pretty sure it was. Yeah.
So the stapedius is a tiny little muscle that attaches to the stapes. If y'all remember from talking a few weeks ago. The stapes is the smallest bone in the body. It's in the inner ear. The stapedius is a muscle that attaches to that. Don't ask me exactly what it does.
Those are not muscles that we deal with.
I think it's something about controlling the vibration and allowing the...
But hey, good job, James. Good job on getting us that answer. That's awesome.
What about the biggest muscle?
Yeah, we still got to get an answer for the biggest muscle. We'll see if anybody can get us that one as we go through.
Google it, I'm sure. All right, so back to the types of muscle. We got skeletal, smooth, and cardiac. We're going to be talking mostly about skeletal today.
All right. Skeletal muscle. All right.
Yep. So this is, like we talked about, it attaches to the bone, but it's what gives the body the power and the strength. The bones are what move and give you form and function, but the what actually gives your body power is the actual muscle.
And it's actually the length of the muscle and then how it contracts. So the length of the muscle is directly related to the amount of power that it can give you. And we're going to show a cool video in a little bit that kind of shows you how that happens. Yeah,
and muscles that attach, muscles are attached. What's the best way to explain this? Basically, bone to bone, but it's across a joint.
You got a picture coming up.
And I got some pictures coming up to better explain it. But we use muscles, skeletal muscle, to do all kinds of activity. Whether you got big muscles that you use when you're jumping or running, but even smiling, frowning. But I mean that we're all using muscles. We got all moving your eyeballs. That's what you got, muscles that do that.
I like smiling better.
I do too. But...
All right. So good. So this, like we're talking about. So
I must be coming up.
Yeah, it's coming up. It's coming up. So you got muscles in your head and your neck that make you that help you do all these different facial movements and move your neck from side to side and back to front. So there are all muscles that help us move there. Go to the next one. Let's see. Yeah, muscles in your arms. So muscles that are around the shoulder here. So when you touch your shoulder, you feel this soft tissue right here, and those are your deltoid muscles. There's actually 3 parts to the deltoid muscle. I think you got a little laser. Oh yeah, you got it right over there.
Yeah, here's the deltoid right here.
Deltoid, and that's what helps
right here.
That's what can help you move your shoulder in different directions, along with some deeper muscles called the rotator cuff muscles, which are a lot smaller and harder to show on a
But it's if you were to peel up these muscles right here, the rotator cuff muscles would be underneath that.
And then there's other muscles as we go down the arm. So the biceps muscle, which is the easy one that you see when you make a muscle with your arm. The triceps muscle in the back of your arm. So the biceps helps flex the arm. The triceps helps extend at the elbow. And then down your forearm, there's different groups of muscles in the forearm that help you flex and extend your wrist. They help you rotate your forearm. And so, compared to the number of bones, we have a lot more muscles because we have some muscles that do almost the same function. There's some redundancy kind of built in, so that if you have one muscle that's not working well, you may have another one that you can strengthen that will that does almost the same job.
And you'll see that a lot of. Well, we don't really go into all that, but there's a lot of that in your legs because your legs are very powerful.
Yeah.
But another thing in your forearm here. You notice you have muscles in your forearm and in your wrist, but you don't actually have any muscles in your fingers. They're actually connected to tendons in your fingers that are attached all the way up here in your forearm. So it's muscles in your forearm that actually move your fingers. That's pretty cool. Yeah. So in your trunk, trunk is basically your torso. It's your abdomen and your back, and that's what keeps you standing upright so you don't fall over. Allows you to bend, rotate, do all that. I thought these were some cool pictures. Mainly, look at how many muscles there are.
I always think this is amazing.
Yeah. When I was actually showing this slideshow to my husband last night, he made me stop at this screen just so he could see all that because it's just crazy to think that you have that many muscles in your back. And this side is kind of on the outer surface, and if you were to peel back these muscles on the top here, you have what's underneath on this side. So that's just pretty amazing. Yeah. That's pretty amazing. Super
important to keep those muscles strong too. A lot of times, if our backs hurt and things, it's actually because we've got some weakness in these muscles that a lot of times we term core muscles. And then on the right hand side of the screen over here, obviously you have the muscles not on the back, but on the front side, which are your abdominal muscles. And,
again, there's layers to all that as well.
Yeah, and all these muscles here in the abdomen and the back are helping to support us when we're standing upright. And when we're flexing and extending our backs or rotating and everything, it does that. But these muscles are really active all the time. And just when we're standing or getting up from a seated position, even when you roll over to get out of bed, you have to use all these muscles. So if you've ever, kids, you probably haven't because these muscle strains are less common in you guys, but you might have. But adults, if adults are listening, it's fairly common, if you have a muscle strain here in your back or maybe a muscle on your side, one of the oblique muscles in the abdomen, they can really hurt with pretty much any movement.
Yeah, it's common to kind of get some when you pull a back muscle, it's common to get little tears in these muscles right up in here. And then I think James, Dr. James Google, has the correct answer for the largest muscle as well, which is your gluteus maximus. It's a muscle that's in your bottom. This is it right here. Okay.
Good one, James.
Good job.
All right.
So that's muscles in your abdomen and your back, which make up your trunk. Muscles in your legs basically go from your hip and your pelvis all the way down. That includes your thigh, which you have your quadriceps in the front, and then your hamstrings in your back, or in the back of the leg. quadriceps. Quad meaning four. There's four muscles that make up your quadriceps musculature and common tendon, and then there's three hamstring muscles in the back. But there's a lot of other muscles in your thigh region. We're not going to go over all of them, but and they have a lot of overlapping functions as well. And then you have muscles in your lower leg. Primarily, what you think about is in your calf. But this is the front. This is the back. Okay, so this is the front. These are your quadriceps muscles here. There's actually a muscle on the front of your lower leg down here called your anterior tibialis. And then on the back here, here's the gluteus maximus. And then your three hamstring muscles, and then your calf muscles down here, your gastrocnemius and your soleus up underneath it.
Yeah, and we decided we weren't going to go into the names of every muscle because that would be a lot to kind of just start naming muscles and things. It's actually certainly something that if you're interested in, you find some cool pictures like this, and that'll tell you the names of every one of these different muscles and what their different functions are and things. So
we have a hard enough time just keeping this to under an hour. If we talked about every, if we talked about every single muscle, y'all would quit watching way before we were done. So. All right, so those are the muscles in the leg.
All right, so let's explain this. So this is kind of what we've been thinking about. We talked about how muscles are attached to bone and how actually a muscle in your arm can go across two joints from your shoulder all the way down to the elbow. So what do we have here?
So this is actually the biceps muscle, but this really is what all muscles look like in the body. A little bit different lengthwise of the various tendons, but this is the basic concept of muscle and how it attaches to the bone. So you'll have an attachment up here, and then this is the tendon. This white piece is the tendon, which comes into the muscle belly. There's some overlapping of the muscle belly over the tendon because the tendon, it's not just a straight shot like it's taped into the muscle. It fans out.
Yeah, we call that the musculotendinous junction, and it's actually kind of a common area where we see injuries occur.
You'll see it'll just kind of peel up off the tendon a little bit. But then, so you go from bone to tendon to muscle belly, and then you go back the other way. You have the myotendinous or the musculotendinous junction again into the tendon, which attaches to the bone.
And this is a good picture of the biceps because there's a tendinous portion on both sides. So some muscles actually start more kind of on the bone. They still have a tendinous attachment to the bone, but they can look a little different than this. But this is a great example. And so what you can see is that, so where the tendon that attaches up to this bone on the shoulder called the coracoid up here, if the muscle pulls that way, then this tendon that attaches to the elbow is going to pull the elbow into flexion. And it's going to do that because the biceps is attached on both sides of the so there's tension on the muscle. And again, this all has to do with the length of the muscle, and then it contracts and shortens, and that's what helps things move. And we're going to show you guys that in a minute because that actually is a really amazing process.
Yeah, we're going to show you actually how that muscle contracts or flexes, as we call it commonly. Just when we say show us your muscles, and you're showing us your muscles, it's the I wish I could keep wanting to do that, but this muscle actually shortens, and that's what gives you that pop-up muscle look. So basically, you have bone to tendon to muscle to tendon to bone.
I was looking at some comments. I had a good question a second about what happens to those muscles during a reverse shoulder replacement, and I think that question was probably about like the rotator cuff muscles. Well, so that's an interesting question. A reverse shoulder replacement is a type of shoulder replacement that we do that basically replaces for the rotator cuff. So actually, for the most part, and as a general answer, you actually don't really need the rotator cuff muscles.
You may still have some muscle there, but it doesn't really serve.
Yeah, this big muscle, the deltoid, is then really what moves the arm. So good question.
All right. Yeah, Brady was asking how long tendons are. Yeah, they can vary in length. They can be super long. There's a muscle in your lower leg that has a tiny little muscle belly about like that, and a super long tendon that goes all the way down. But some of them, some if the muscle's coming off of the bone,
the tendinous portion is very short.
The tendinous portion is extremely short.
But if you think about these, the muscles in the forearm, we talked about the muscles that move your hand. Well, those have very long tendons because the muscles are actually way up here in the forearm. And then the tendon, actually, the tendons start about this level in the end of the forearm here, and then they're tendinous all the way down to the tip of the finger there. So that's a really good question, and the answer is it's different for different for different muscles and different tendons. So yeah, let's keep going here. Okay. All right.
Now we start getting into the good stuff here.
What we think is the good stuff anyway. So that muscle that we look at, that kind of looks like a big piece of meat on a lot of those pictures. There's a lot more to that. And just like everything, when we took bone and we started looking down at the different layers of it, when we look at a muscle, we look at the big picture of the muscle. But if we kind of dive down inside and things we can see under microscopes and things, we find that there's really a highly organized structure to every muscle fiber that you have. So our muscles.
So you start off with this. This is the big muscle. Like when we think about muscle, we have the big muscle belly, the body of the muscle that we talk about.
And then there's multiple fascicles of muscle fibers.
All these little encapsulated things are what we call the fascicles. And here's one that they've pulled out.
Right. Opened that up and looked inside and even a deeper layer.
Within that, you have even smaller clumps here that are links that are called the myofibrils. Okay.
The myofibrils, the myofibrils or the muscle fibers in general, they're actually big elongated cells, and they have multiple nuclei, which is kind of the central portion, kind of the brain of a cell. And then these myofibrils are even divided further into things called sarcomeres that contain these small little filaments called actin and myosin. I think we go to the next slide.
Yeah, I remember actin and myosin.
Yeah, I remember that because they're actually ultimately our big old muscles that move and let us lift
big
things
muscle belly. We started
run.
off with the big muscle belly.
Yeah.
That you think about, and we're down to the tiny little filaments.
And without these tiny little filaments, we couldn't move.
Nope.
They wouldn't do anything.
Nope.
So yeah, it's pretty awesome.
So here's another kind of little breakdown here. So we start off with the biceps is just. I like that they continue to use this because it's a muscle that everybody can relate to because you can always see it right there next to you. But so you start off with the big muscle belly, and go down into the fascicles, into the fibers, into the myofibrils. You'll see myo used a lot when you talk about muscles. That's just basically means muscle. Yeah. And then within the myofibril, you have these connecting sarcomeres.
Sarcomere, that's a good word.
Yeah.
That's like almost as good as I.
And then here, these right here, these little skinny and a little bit thicker little filaments are your actin and your myosin.
So your thin filaments are the actin, little thicker filaments are the myosin.
And I think we've got. Is there a slide?
Up picture.
Oh yeah. So how do the muscles move? Actin and myosin.
So these two proteins are actually what cause. They're where all the work happens. That make our muscles move. These tiny little protein, these tiny little fibers in our muscles. So what are these things here?
So we kind of mentioned this, but they're tiny little protein filaments, and you'll see protein mentioned a lot as well. It's the protein or the building blocks of your muscle. You have to have these proteins to get your muscle stronger, all that. But it's a bunch of proteins. But these actin and myosin are two types of these protein filaments that slide across each other that make the muscle shorten.
Yeah, and this is a motor.
Yep.
I mean, that's what this is. This is a motor in your body. It's just a biologic motor that's controlled by different types of molecules and things. And
we got a little video. We got a cool little video. We're going to go over this with you.
Yeah. All right. So are we video now?
Yes.
Okay. All right.
Yes.
Yeah, and so we thought that a video would be the best way to show you how this works.
Come on. Let me just get rid of this. Y'all bear with us for just a second.
Technology, we're getting better, but it's not always smooth.
Yeah, the cursor went away.
Oh.
There we go. Close this out. Because I think it's sometimes related to having too many things open.
But what we're going to see in this video that we're going to show is we're actually going to look, we started out looking at kind of the big picture. We watched some athletes who hurt their muscles. And we are at the end. I saw a question a second ago about how long it takes a torn muscle to heal. We're going to answer that in just a few minutes. but we looked at athletes running and hurting their muscles. Then we talked about kind of the big picture of kind of what our muscles look like. Then we talked about how the tendons attach muscles to bone. Then we looked inside the muscle. And now, I mean, what we're doing here in this is we're looking deep inside the muscle at each individual sarcomere and these small proteins called actin and myosin. And you'll get a real good picture here of how why our muscles contract. So
if you can see the little before we start the video, you can see the little
purple lines that go up and down, the Z lines.
Yeah, I know. I was trying to get the cursor to work, but I can't get it to work. But yeah, so the purple lines you see going over the Z lines, and between those purple lines is what that actual sarcomere that we're talking about, and you can see the actin and the myosin, and we're going to zoom in. The video's going to take a zoom in. Don't worry. Come on.
Oh, I see.
My cursor's gone.
There we go.
All right.
Reappeared.
All right. So here, this is kind of the basic.
There's the muscle.
There, we zoom in right
out.
there.
Okay, and these
so
little purple
right
things are called myosin. So the myosin is, so we can't see the cursor. Nobody can see the cursor, right? So the kind of the brown filament with these little purple balls coming off of it, that's the myosin protein. And then actin is that kind of red helical looking one that has red and then it has yellow dots on it. And what you're going to see is that those small little purple things on the myosin will attach to the actin, and then they will pull it along. Is what they're going to do. So we watch there, that myosin. You're going to see it pull the actin. And so imagine as your muscle is contracting, and I know we can't see us right now, but as your muscle is contracting, like if you bend your elbow and contract your biceps muscle, deep down inside, that's actually what's happening. Is these proteins the myosin is pulling the actin like that and shortening that sarcomere. So
yeah, and I think it'll zoom out in just a second, but yeah, that's pretty daggum neat.
Yeah, and so there's even more going on here. There's always more layers. I mean, our bodies are so complex. So that small thing there you saw called ATP, that's kind of the fuel for this whole reaction. And so this molecule called ATP binds to the myosin. The myosin.
I missed out on the very front of this.
Do what?
I think there's a part of this I missed out on, huh?
What do you mean? That's okay.
Okay.
Yeah. And then myosin breaks down ATP into those two molecules, and that's what that's what activates it to go bind to the actin binding sites, and then it's going to pull the actin along. Mm-hmm. And then what's going to happen is another ATP molecule is going to come in, and that's going to release it. And so I'm getting ahead of the video here.
No, because I think
no, yeah, there we go.
Yeah. But I think there's one at the beginning where it talks about the nerve coming in.
No, it's later in this video.
Oh, is it?
Yeah.
Okay.
Yeah. We looked at a bunch of videos that we want to try to show you guys. So again, there ATP coming in, it's going to release the myosin, it's going to break down ATP, that's going to activate it to pull that actin along, and that's how your muscles contract. And so even more than that, though, what has to happen is you got to have calcium that comes in and actually allows there to be a place on the actin for the myosin to bind. So again, I'm not showing you this because you're going to have, you expect you guys at your age to kind of remember all these things about these different molecules and the names and everything, but just to show you really just how amazingly complex this is. Something that's so routine that you think about every day. Mm-hmm. You think about just getting up out of your chair and your muscles contract to do that. But all this is what's actually going on inside your body that you're not even thinking about to make this happen. And actually what's coming up on the screen now is a nerve ending. So the only reason that any of this happens is because there are nerves that attach to your muscles. And when you get a signal that goes down this nerve, it actually causes something called depolarization at this thing called the sarcoplasmic reticulum. There's some just awesome vocabulary words here. Yep. And then that's what allows, ultimately, by a much more complicated process, allows this calcium to be released into the muscle, allows the actin binding sites to be opened, and then allows this reaction that occurs with ATP, to allow the myosin to bind to actin and pull the muscle and contract it. So here what we see, so that was something, a depolarizing conduction happened in the nerve. So something called acetylcholine got released there, and now you see what these flashes are is kind of that nerve conduction going down across the muscle, which caused a release of calcium. The actin binding sites got opened up, and the myosin can now bind to the actin and contract the muscle. And then here what you see is what ultimately that causes is contraction of the whole muscle. So we went from kind of way down inside the muscle, and now we kind of moved out.
Whoa.
What you see is, right, while that's going on, that's making that whole muscle contract. And what it's really allowing is for somebody like you to be able to move their hand to write.
Pretty cool, huh?
So it's just an amazing process, and such an amazing orderly process that the way that this happens, and so we think it's cool.
We think it's cool.
You guys,
but if
think
you just,
that's
I mean,
pretty
think
cool
about
too.
it. That and this, like, that was a muscle in the hand they were showing you, but that occurs even in the biggest muscle of your gluteus maximus, Dr. James Google. So and it's just more of them. So you have the actin and myosin within the sarcomeres, and so the bigger the muscle is, the more sarcomeres along that filament you have. So.
And then even more complicated, they can have different lengths and different things. But anyway, that's not for today.
That's not for today. That is not for today. So, and how do I get rid of that right there? All right, so moving on.
Yeah, I think we're good because that's what we're seeing.
Yeah, I was just trying to get rid of it.
All right, so muscles can get hurt. A couple of guys had asked some questions about this. So pulled muscle or a torn muscle, like those videos we showed you at the beginning, that's what was happening with those athletes. They can tear partially, like the middle picture you see here, or actually even the picture all the way on the left can be just kind of a little contusion or bruise in the muscle. They can partially tear, or muscles can even completely tear. And like we said, a lot of times injuries that happen at muscle happen at that myotendinous junction where the muscle and the tendon come together. There can be some weaker points there where the tissue types change.
This picture shows the different grades of muscle as far as the grade 1, which is very mild, to a significant partial tear to a full thickness tear, and it shows it across the muscle belly. But this can occur, anywhere along that muscle or the tendon, like he was saying. Now, injuries occur when you're basically making it do too much, whether it's you trying to lift too much or just from an injury where you get in a weird position and it gets
the muscle
pulled.
Stretches farther than it's supposed to.
It stretches farther than it's supposed to.
Yeah.
So.
Yeah. So let's go. So the next one's about kind of how they. How do you treat a muscle injury?
Yeah. So we love to use rice. Okay. Now
not like in your cabinet.
That's not like the rice in your cabinet that you eat. It's just it's abbreviation for what we use as rest. And I say on here it can range from a few days to a few months. It all depends. Back to this slide here. It all depends on how badly torn it is. A mild little tear like this, which is if you're just what we call, sometimes you may say it's just tweaked. Or maybe we just say it. I don't know.
But a mild strain, which is certainly the most common thing that we see.
That's when you tweak your muscle, and you may take a little ibuprofen or something like that, and after a few days, you're back to normal. If you pull a muscle in your neck, say you have a crick in your neck, kind of the same thing.
Yeah.
And it just after a few days, it'll go away. Versus something that's more.
Partial tear completely through the fibers, like what we see with hamstring injuries a lot.
Mm-hmm.
That's real common. We showed you those, the sprinter and the baseball player who hurt their hamstrings. This is more often what happens there. You actually do get a tear, and we'll show you I think another slide in a second. You get a hematoma that forms in there, and so those things that's why you see athletes or not even just athletes, but anybody with those injuries. It takes a little while. I mean, those injuries often take 4 to 6 weeks to completely get over. So
something like that. I mean, if you're a professional athlete and you get something like that in the middle of the season, a lot of times, depending on how much longer you have, sometimes you're going to miss a good portion of that season. Yeah, back to the rice, and then ice compression and elevation is just kind of the standard from an early on standpoint. But back to the rest, sometimes those complete tears, like we talked about over here, it's not often you get a complete tear through the actual muscle belly. Usually, it'll occur within a full tendon. Or up here in the myotendinous junction, or you'll just tear it completely off the bone. And oftentimes, we have to repair those. Yeah. There's a few times we don't, but most of the time, those are injuries that we have to repair surgically. So, and then as far as the healing.
So very similar thing to what we looked at in bone,
Mm-hmm.
right? So the very first thing that happens, so right when that muscle tears, it bleeds, and so you get this kind of clot of blood that forms. And it's not a bad blood clot. This is just what we call a hematoma that forms at the site of the injury. And so then what happens over kind of, and again, we had a question about how long it takes this to happen. So most of the time, this is a process that happens over a couple of weeks. This clot will start to shrink, and basically what happened inside that clot is you had all these different types of blood cells in there that start to form this fibrous tissue, which is basically this early kind of scar tissue that happens as the muscle heals. And then over time, again, you remember like we talked about with bone, it formed that kind of woven bone that was very disorganized, and then it started to organize and line up again. That's what happens in muscle as well. But make a point here, because we made a point with bone the other day where we said, hey, when bone heals, it heals with bone. And if you looked at that tissue under the microscope again, it would look just like normal bone. Not the case in a muscle. Or most soft tissues. Actually, even after you get complete healing, if you really look down at that tissue after it was healed, there's some scar involved there. There's some fibrous tissue. It does regenerate to the point where it can still contract, but it's not like it was originally. So in most tissues in the body that way, and again, that's one of the things that we think is so cool about bone, is that it doesn't do that. It actually heals exactly like it started.
Yeah. But this process, like he said, it typically takes a few weeks, but if it's something that, if it's a massive tear and more of it,
the more disruption you have in the muscle fibers, and the larger the hematoma that you get, the longer it's going to take.
Yeah, and with bigger tears, where you can't, where you have to, it may take the same amount of time for it to heal, but you have more of it that you have to build back up afterwards if it's a big tear. So sometimes it's not so much the actual healing of the muscle; it's the building back up of the strength that takes time. So
cool. Oh, awesome! Hey, we kept it under an hour.
Y'all.
38 minutes.
Okay.
So yeah, man, if you guys have any questions, we'd love to sit here and take questions for a few minutes, and they can be about anything. I mean, they could be about bone stuff we've talked about the last few weeks, or they could be about some things that we talked about here. Hope you guys thought this was interesting. A little different topic this week, and I know diving down and showing that video with the actin and myosin might seem like that's a little too detailed, but part of the thing that we really like is we love what we do, and this stuff is really interesting to us, and I love being able to show people kind of these big things that you don't even think about doing all day long, but what's really going on, at a deeper level. And honestly, I hope if anything, it maybe just kind of gets you interested, and maybe where you want to maybe go learn about it some more. And it might be something you want to learn about and know about for a long time. It might be something you want to do in your life. So,
and that's kind of
cool.
what started this whole thing with us, is just teaching kids a little bit and just piquing your interest and wanting you to learn a little bit more. Some people may not have any interest in this. So some people, hey, maybe you do. Maybe you didn't know you did until you started learning a little bit more about it.
At least 9 people do.
Yeah. Well.
So, all right. Let me scroll back up through and just see if there's any other questions.
Hey, Chris. Not sure if you're still watching.
Yeah. Hey, Chris. Awesome. Miss you too. Yeah, actually, I think we've kind of answered everything along the way here too. I don't see anything that we haven't answered.
We've kind of learned that as we go. Is we'll try to.
Yeah.
Because sometimes we forget to look down and look at what the questions are, so we try to give as much information as we can with all of this. All
right. Well, if there's no questions, we're going to sign off for today, guys.
But again, feel free to ask if you're watching this at a later time. Put some questions in the comments, and we'll get back.
Yeah, we'll definitely go back and answer them.
If there's, I'm not sure how many more sessions of these we're going to have, but if there's anything y'all want to know more about, just
let us know. Because like I said, we are going to try to do this as long as we can, while we have some time during this coronavirus situation where we're not quite as busy with surgeries and things, and want to be able to connect with you guys and try to help out how we can. So if you have any ideas or things you'd really like to know about, please let us know. All right, guys, signing off.
Peace out.